Hello students, welcome to daily practice session. Myself Devi Prasad Padmar. So today let's solve one problem related to electric field due to a point charge or due to a system of charge. Okay, so before discussing about that, we must know that expression which we require to solve this problem. Okay, so that expression is nothing but electric field due to a point charge. Okay, so what is that expression? I hope you know this concept, so just revise this. So electric field due to a point charge. Okay, electric field due to a point charge. Let's consider a charge. Let it be some charge q. Okay, now at certain distance from this charge, let the distance be r. Okay, at certain distance r from this charge, there is a point P. Okay, let's consider a point P at a distance r from the charge q. Okay, so as I said, this what about this distance? That is r. Okay, r. Now at this particular point, what is the expression for electric field due to this charge plus q? And the expression is given by electric field E equal to 1 by 4 pi epsilon naught q divided by r square. Actually, it is a vector quantity. Okay, electric field is a vector quantity, right? Now this is the expression for electric field due to a point charge at a distance r. I am writing just in magnitude. Now if you want to write this in vector form, so here you need to consider vector E, and here one r cap you need to consider. Okay, because electric field is always outward from a positive charge. As I said, this plus q here, right? Sorry, that charge is plus q. Therefore, electric field is outward from that. That means here at this particular point, if you need the direction of electric field, that will be normally outward. So at this particular point, electric field, yes, the electric field will be along this direction, right? So this is the direction of electric field. Okay, and the expression is given by 1 by 4 pi epsilon naught q by r square. And from this, it is clear that how this electric field depends on the distance of that point from that particular charge. How it is proportional to r, how electric field is proportional to r. So from this, it is clear that electric field is inversely proportional to r square. Electric field is inversely proportional to r square. And also you can just simply rewrite this expression like this. You know, this 1 by 4 pi epsilon naught, that can be written as k, no? Therefore, electric field can be written as electric field E, that is equal to k into q by r square. Okay, k q divided by r square. Like this also you can write the expression for electric field. I hope it is clear. And then what about unit of electric field? Please remember, the SI unit of electric field is nothing but Newton per Coulomb, or it is also known as, it can be written as volt per meter. So both are unit of electric field itself. Okay, Newton per Coulomb or volt per meter. Okay, this much data is enough to solve today's problem. Okay, so let us discuss that problem related to electric field. Okay, actually that is related to electric field due to system of charges, and here I have considered only a single charge. Okay, same concept if you want to apply it for system of charges. Let's consider some charges q1, q2, q3 like this. Okay, all are plus or minus, you can consider, no problem. Okay, generally I am considering plus charge, and let this be some point P. Now this point P is at certain distance r1 from charge q1, and let the distance from q2 be r2, and the distance from q3 be r3. Okay, so from q1 it is at a distance r1, from q2 at a distance r2, and from q3 at a distance r3. So due to point charge, you know that expression, so E equal to, what is that, 1 by 4 pi epsilon naught q by r square, or you can write it as k q by r square, that is for a single charge. So if you apply that for system of charges, then the net electric field at this particular point, there is nothing but sum of electric fields due to these individual charges. So field at point P due to q1 plus field at point P due to q2 and due to q3. So how to get an expression for that now? So here if you consider q1, electric field due to q1, that will be along this direction. Electric field due to q1, let it be E1. Okay, E1 is along this direction, and due to q2, that will be along this. Okay, along this, so E2, right? Similarly, if you consider it for q3, that will be along this, E3. Now if you add all these electric fields, you will get net electric field at the point P. Okay, therefore we can write electric field, net electric field, E net is equal to vector E1 plus vector E2 plus vector E3. Okay, so like this you can add individual electric fields to get the net electric field at any point. Okay, so again if you want to write expression for this, 1 by 4 pi epsilon naught is common, right? So we can just write like this, E net. Okay, I'm just writing in terms of magnitude. Okay, so E net is equal to 1 by 4 pi epsilon naught is common into q1 by r1 square plus q2 by r2 square plus q3 by r3 square. So this gives the expression for net electric field at the point P due to these three system of charges. Okay, like this if you have n number of charges, same you can continue up to qn divided by rn square. Okay, I hope now it is clear. I have written that just in magnitude form. Okay, just you can consider vector form also. If you consider vector form, how you have to write vector E net, that is equal to 1 by 4 pi epsilon naught q1 by r1 square into r1 cap plus here q2 by r2 square into r2 cap, q3 by r3 square into r3 cap. Okay, like that you need to write. Anyhow, this is enough for today's problem solving. Okay, so let's move on to that question. It is related to the same concept. Okay, so here we have, okay, here is a question, and given that 6 point charges are placed at the vertices of a hexagon of side 1 meter as shown in the figure. You have the figure here. Now net electric field at the center of hexagon. Net electric field at the center of hexagon you need to consider. That means it is related to system of charges. As I said earlier, it is related to system of charges. So how many charges are there? As per given problem, how many charges are there? Hexagon, on each vertex you have one charge. That means total 6 charges are there, right? So due to this 6 charge on the vertices of this hexagon, what is the net electric field at the center? So at the center O, what is the net electric field that you need to calculate, right? So please remember, the direction of electric field is always from positive charge to negative charge. If you consider positive and negative charge, here we have positive charge and negative charge. Just look at the diagram. Just look at this. Here we have negative charge and here we have positive charge, negative, negative, positive, positive. So you must know the direction of electric field. If you consider positive and negative charge, so it is from positive to negative. If you have both the positive charges, then higher magnitude to lower magnitude, like that you have to consider. Okay, anyhow here positive to negative. So how to solve this? Okay, let this be that hexagon. Here you have minus q, so charge minus q, minus q, minus q, and this one is plus q, and this one is also plus q, and this is also plus q. Now at this particular point you need to get the total electric field. So always, if you want to calculate electric field at any point, you need to place a unit positive test charge at that particular point. That means here at the center O you need to calculate electric field, no? So let's consider some unit positive charge at that particular point. Okay, you can consider plus q naught, like that. Anyhow, so unit positive charge or plus 1 coulomb you can consider. Okay, let it be plus 1 coulomb. Okay, 1 coulomb. Anyhow, now here certain charges are positive, certain charges are negative, right? Now let's consider one particular charge. Let's consider this charge. Now this is positively charged, and due to this charge, and given that each side of hexagon, the length, each side of hexagon is of length 1 meter, right? This is 1 meter. 1 meter is also 1 meter. So if you consider regular hexagon, this is also 1 meter you will get. Okay, so each length, these are all 1 meter itself. O2, this charge, from each charge the center is at a distance 1 meter. Okay, right. Now if you consider this particular charge, due to that charge, what is the direction of electric field at the point O? So from positive charge it is always outward, no? Therefore here if you consider the electric field due to this charge at this particular point, then the direction of electric field will be along this direction, because it is from positive to negative, or here actually smaller positive charge is kept at this particular point, smaller positive charge is kept at this particular point. Therefore the direction of electric field at the point O due to this charge will be along this direction. Okay, similarly okay, let its magnitude be E. Okay, E is the magnitude of electric field at the point, at this particular point O due to this charge. Similarly, due to this charge, the direction of electric field will be along this direction, no? Right? So sorry, here you have minus q. Okay, this is also minus q. Anyhow, now due to this charge, electric field here at this particular point, that will be along this direction, and again the magnitude is same, right? Similarly, if you consider this particular charge, again the electric field at this particular point O will be along this direction, right? Then what about magnitude? Again the magnitude is E, right? I hope it is clear. So due to this charge, electric field at this particular point will be along this direction. Similarly, due to this, electric field is along this direction, and due to this, electric field is along this direction. Okay. Similarly, now consider negative charges. Negative charges. Now if you consider this negative charge, and you know here you are keeping a unit positive charge, right? Now due to this minus q, what will be the direction of electric field at this particular point? As I said, the direction of electric field is always from positive to negative if you have positive and negative charges, right? Therefore, here you have positive charge, and this one is negative charge. Therefore, what is the direction of electric field at this particular point due to this charge? There is nothing but along this direction, right? Then what about magnitude? Magnitude will be E itself, right? Similarly, due to this charge, what is the direction of electric field at this particular point? That is always from positive to negative. Okay, then what about magnitude? It is also E. Similarly, due to this charge, again it will be from positive to negative. Then what about magnitude? That is also E, right? Okay, so E and E acting along this direction. Here also E and E acting along this, E and E acting along this. That means we can consider here net field along this is 2E, here also 2E, and here also 2E, right? Now as I said, it is a vector concept. So 2E acting along this direction and 2E acting along this direction. Now what is the angle between these two? So this, if you consider complete line, that is 180 degree, and now the angle will be equal to how much? This is 120 degree, right? So this angle is 120 degree. Angle between this 2E and this 2E, that is 120 degree. Okay, so two vectors are acting at 120 degree. You can calculate resultant of that two vector, and resultant of that two vector will be along the diagonal of the parallelogram. That means resultant of this 2E and this 2E will act along this direction itself, and in that direction already one vector is acting. What is that vector? 2E. So 2E is acting along this direction. Along with that, resultant of these two vector, it will also act along same direction, right? Therefore, what is the net electric field at this particular point? That can be written as net electric field, E net, or just magnitude we require, right? So E net, that is equal to value of net electric field, E net, is equal to root of, that is E1 square plus E2 square. That means here 2E square plus 2E square plus 2 times E1 E2 whole square. That means they are acting at an angle, they are acting at an angle 120 degree, no? So 2 E1 E2 cos theta. So E1 is 2E and E2 again 2E, and angle between them is cos theta. Theta is 120 degree, and plus, so to the resultant of these two 2E, one more 2e must be added because that 2e is already acting along that direction. That means you can write this as plus 2e. Now just you need to simplify this. So what do you get? This will be 4e square plus 4e square, and this becomes actually cos 120 means minus half, right? Minus half. So this 2 and 1 2 get cancelled, so remaining term is 4e square, okay, and plus this 2e. Just simplify this. So 4e square plus 4e square minus 4e square get cancelled, so root of 4e square plus 2e. So root of 4e square is nothing but 2e plus here 2e. That means you will get 4 times e. So E net, that is equal to 4 times electric field due to a single charge. Electric field due to a single charge. So what is the electric field due to single charge? Electric field due to single charge is 1 by 4 pi epsilon naught q by r square, right? So but r value, what about r value here? Distance value, that is 1 meter, therefore r equal to 1 meter, right? So r square means that will be 1 itself, r square equal to 1 itself. So this is the value of E. Just substitute this value of E in this. So finally what do you get? So if you substitute E value, so we get E net, that is equal to 4 times 1 by 4 pi epsilon naught into q. So this 4 and this 4 get cancelled. So finally net electric field, that is equal to q by pi epsilon naught, q by pi epsilon naught. I hope it is clear, right? So q by pi epsilon naught. So net electric field along this direction, that is equal to E net equal to q by pi epsilon naught, right? So but r value, what about r value here? Distance value, that is 1 meter, therefore r equal to 1 meter, right? So r square means that will be 1 itself, r square equal to 1 itself. So this is the value of E. Just substitute this value of E in this. So finally what do you get? So if you substitute E value, so we get E net, that is equal to 4 times 1 by 4 pi epsilon naught into q. So this 4 and this 4 get cancelled. So finally net electric field, that is equal to q by pi epsilon naught, q by pi epsilon naught. I hope it is clear, right? So q by pi epsilon naught. So net electric field along this direction, that is equal to E net equal to q by pi epsilon naught. If you look at the options, here is our option. There is option C. Okay. Yes, thank you. If you like this video, please subscribe my channel, okay, and please share this, like this, okay. So your support is very important, so that it motivates me to create some more videos related to same topic, okay. Thank you.